Hello everyone and welcome back to the third video of Ardamax Keylogger. Welcome to my YouTube channel. My name is Uriel Kosaev. Let's get going into our interesting stuff. So in the second video we were debugging the first stage and analyzing it, and we understood that it goes to the resource section, extracts a cab file, which is kind of like a RAR or zip file, and basically from there it uses the FDI copy function in order to drop the two files. Actually, one is called one.exe and the second is called install.exe, which we already saw in the resource section using the resource hacker tool in the first introduction video of Ardamax Keylogger. So basically we saw that it first checks whether the file exists or not using the basically it uses the FDI copy, but if we see it on the process monitor or procmon, we'll see the operation of create file. So first of all, it tries to receive a handle to an existing file, and if the file does not exist, it goes and creates it. So the first file created is one.exe, and you see after the create file we have write file. Basically it writes the buffer of the data to the actual created file object, and from there it goes to the second file, and again you see the same pattern. The result is name not found, and after the file is not found, it goes and creates it, and again writes the file to the disk. Okay, so basically if we go and do right click jump to, we can see that it will go to the actual place, to the actual folder created in the temp folder. Okay, so now we want to kind of understand what goes afterwards. Okay, so we dropped two files, what now? Okay, so let's continue. And again, as a reminder, I did not analyze those stages beforehand, and I'm doing this from scratch. This is the concept of those videos. Okay, so let's go and continue analyzing basically the code, so we can do F4 here to free the resource that is already used. Let's see before what kind of function we have here. So load some strings, does some stuff. I don't see something interesting here for now, so let's do F4. F4 is like putting a breakpoint, executing till F9, and basically that's it. So in either Pro, F4 will do the same. So now it goes, it takes an argument of the resource section of the cap file, and now it will do free resource. Basically it's like receiving a handle to a file and then releasing the handle. So it goes the same for resources, and we'll continue, and then it will go out of this function. So basically this is the function which drops. This is the function which drops the two files. So this is our dropper function. I'll put the here convention so we can easily find it in our functions video, functions window. So we'll jump and then go receive something in RCX. See that it will go and call this function, and again go for another resource inside the file. If I remember right, I put a breakpoint here because I think it will call something like an indirect call or something. So I think it can be very interesting. So let's interesting here, or maybe. So let's go inside, F7 to go inside, go do some security checks, stack canary stuff, goes to this section in the resource, finds it, then goes to a jump and return. So actually for now I think it will not go here, but pretty interesting. So let's see how many times it is called. It can be potentially called 2 times. Okay, so let's continue. I'm trying to understand when the stages will be called. So we'll see the create process or something like this. So if we go to filter, just to be sure, yeah, I just want to make sure that we receive all the events. Okay, so for now we can do Control X to clear the events and continue with our debugging. Okay, so now it called another thing. So let's see. It's already executed. Got to the session. System current control set. Control session manager. Open the key. Okay. Got to the session manager. So if we go to Procmon, got to the session manager key. Let's see what do we have there. So if we do jump to, it will go to the key itself, and this way we can understand why it did it. Auto check, stuff protection. So okay, trying to understand why it did it. So if we go back to Procmon, session manager, pending file rename operation. Okay, pending file rename operation. So it checked whether under the session manager key we have the pending file rename operations. So it will try to, okay, so it actually has something, it has the key, and try to query a value, some kind of value, and there is nothing for him. Then it closed the key. So basically this is what it does. For some reason, we'll try to understand it later. Okay, so we can just continue, and yeah, the thing that I got to the function that actually calls. Oh man, okay, so we got the function that executes the next stage, which is one exit. So let's, okay, so let's just put a breakpoint and call it call to just next stage. Sometimes you need to be careful, but whatever. Okay, let's stop this process and go to Process Explorer. Try to understand what we have there. Maybe the one exe already executed the install exe or something. So let's go. We have one exe. Let's put it on a suspend right now. Let's see if it spawned. Okay, so it tries to establish connection to an external IP 104.16.154.36 in HTTP. Okay, so how many threads it has? Let's go to security. Okay, so let's try to select columns. I want to see if it does command line argument, if it has some auto start location for persistency. Virus total can help, especially great for incident response and to get some fast information regarding running process and stuff like this. It does not actually upload the process content, but it goes to the image itself, which the process is loaded from the hard drive, and uploads the file itself or the hash. So I want to also see the username context it executes. So let's do like user and auto start virus total. We can do for virus total, we can go to options, virus total, check virustotal.com, yes, it will now open some browser. By default it does it. So we just can close it, and as you can see, hash submitted. So we have here a couple of things. Yeah, sometimes there are false positives also. Let's be on the one exit. So as you can see, it's 50 out of 71 detections. And let's see also regarding command line, we have something interesting here. So basically, it's a regular process created by the first stage malware that we already analyzed. And basically, if we go to procmon, we can see what kind of operations it already did. So let's go. For now, let's stop receiving events. So it got to run once, maybe for for persistency purposes, of course. So it got access denied, so maybe it will then try to escalate privileges, maybe not. Then it got to, okay, so it basically checked if it has already an open instance, and maybe the malware already executed here. So after that, we'll go. So it's still, okay, so this is the execution of the first stage. Okay, so the first stage, which actually execute the second stage. Okay, so now we need to filter for the process name of one exe to see the events from one exe. So yeah, we see here process start, of course, load image, loaded some of the DLLs it needs, and then got in checking some registry keys. I think it's more of default stuff. So checked some things with .NET Framework. Okay, so we're continuing. Did a lot of checks, a lot of tests, so we can go further. So it got WinSock, so we already saw it kind of try to initiate a connection with a specific server. So it would try to take the server itself, like TCP/IP, go and copy, or let's put it in VirusTotal. So do search in a second monitor, 104, 16, 154, 36. Yes, right. Yep, and we see it's actually okay. So no detections. Not surprising. Most of IPs and URLs and domains are very hard to detect as malicious, but the community says otherwise. So if we go to community, let's see, it tries to go to an email. So this is the same behavior we saw already. Feed spy, okay, interesting. WhatsApp, copy, okay. So we can try to learn from those from community, from threat intelligence, maybe check relations, understand what is the context of this file. But let's close it and go and understand. Okay, so the first stage executed it. I want to understand how it executed it. So let's go to the functions. I'll search here the here. Okay, so next stage here, somewhere in this function. Okay, so it goes to the resource key reboot, show window, whatever. So we see relatively big function here. Do a lot of other operations. Okay, so we see here do inf install. What is fun? This function is extracted from some DLL because we see the get proc address here. So let's do search on it. MSDN. Okay, so we don't see, maybe it's a, so it's not on it's not on MSDN. Wine API. Okay. Wine is a software that actually executes or emulates Windows programs in Linux environment. Okay. So it goes and takes setup parameters. ADV pack. So it uses Wine runtime or whatever to install. Kind of weird. Okay. Why will the developer or malware author would want to do it? Okay, so here is the create process. How many times we have create process? Only once. So this is the actual creation of the process, I think. So create next stage process here. So it creates the process, and of course it's not something too complicated. So again, then goes to run once, as we already saw in the Procmon window, somewhere, you know, up there. So it, yeah. So okay. So now it gets to the get system directory, gets the system directory, and do run DLL on something. Okay. So it creates a process1 exe, which initiates a connection with some C2 server. Interesting if this C2 server is up and running. So if I go here, now where is the... Yeah, put it somewhere. Okay, so let's go Process Explorer. Go to the IP 104.16.154. I know I can expose myself or whatever, but let's go and do it. 104.16.154.36. Don't expect too much, but I see here direct IP access not allowed. So let's do a quick whiz on this. Terminal, I have a WSL Kali Linux here installed, so yeah, let's do update, why not? So let's do whiz, oh man, on this IP address without HTTP. So it's like part of, okay, so it's behind Cloudflare. Kind of logic, because if you put something behind Cloudflare, you will not have sensitive information or whatever information, like, you know, addresses, emails, and stuff like this of the attackers or whoever they are, exposed to the public. Okay, so it's behind Cloudflare, so kind of interesting. We can, of course, contact Cloudflare, say, hey, you have a server behind, you know, maybe the server is like in DigitalOcean or something else, but, you know, it's kind of interesting to check. So let's continue with this analysis. So basically it initiates a connection. Now I want to only to validate that the first stage do not do anything else or something weird. So we have here do if install, again we see it. So let's try to understand the context of this function again, like really understand. So I'll do if install, and okay, so let's try to check other things. So let's see what else we can. Okay, so it's part of ADV pack, which we saw somewhere here, I think. Yeah, ADV pack DLL. Let's try to understand from where this DLL comes from. MSDN, Microsoft, whatever, it's just Microsoft. Okay, so let's see. Maybe it's undocumented DLL, which can be very interesting. What? I don't want to create a profile, I want to read about it. Where is the post? Okay. I don't know. I don't think fixed DLL will. Your files will be back. Yeah. As back will create Internet Explorer by Microsoft. Windows Vista. Okay, release for packs found. Okay, so what is the purpose of ADV pack? Vulnerable, has some vulnerabilities or whatever. ADV pack. Okay, so let's use the magic word, malware. Nah, library deliverable information. Nah, we have some Joe Sandbox stuff here. Wine API. React. Okay, so cyber maybe. No, I don't think so. Cyber is too generic. So we have Bing wallpaper X. Okay. Okay, so where is the DLL here? No, don't really see it. Maybe it's on the strings. Let's close it. Whatever. Clean. I don't think so. Okay, so don't really understand why it uses it. Okay, we don't need to really understand everything because it will take much more time to do it. So yeah, for me it's kind of hard to continue with something that I don't fully understand, but sometimes we need to do it. Also, we see run DLL32exe, which is a program which literally loads and executes DLL directly, because DLL files need to have an exe program or exe process which actually loads functions from DLLs, and run DLL basically do the same. So if you don't want to write a executable which loads and executes specific functions from specific DLLs, you can use run DLL32 directly. So it's in C, Windows, System 32, you can see the run DLL32, and you have both 32-bit version and 64-bit version alike. So run DLL, ADV pack DLL, and it loads the del node run DLL, which is whatever function it is. Let's see what is the purpose. So basically the syntax is run DLL exe. It takes a DLL and loads a specific function, okay, or an exported function specifically. So let's search there also. Let's see, okay, so again, very central. Whatever. Okay, we have a blog of Xcorn. Xcorn is one of the great researchers, and especially in Windows stuff. Following him on Twitter also. Okay, because but again, this is good for del no functions for an ADV pack DLL. Quick search. So okay, let's see. Looking closer, function tries to take 2 arguments, not 1, as originally assumed. Okay, this, if the second argument is not present, it is assumed to be 0. Why not checking what the second argument? Okay, so can delete both individual files and whole directories. So it's basically some kind of anti-forensics or deletion mechanism. Okay, so why a software developer or a malware developer want to use this function and not delete file? Okay, so maybe it could be for less detections on antivirus or EDR software. Maybe I don't know. He copied it from another malware which does it, and it basically worked for him. I don't know. It's kind of interesting question. If you want, you can comment on my videos and let's open a discussion about it. Kind of interesting. Okay, so basically, okay, so we have all the flags here. So delete the directory, can delete directories, files. Yeah, pretty interesting. You have malware which actually executes command line or shall execute or literally execute command line or CMD commands like del or rmdir to remove stuff, or they use delete file, Windows API function, or stuff like this. But we can see there are a lot of variations to stuff like this. So let's say Trojan downloader, blah blah blah, goes. So again, we have here, goes to, and again deletes. Oh man, okay. It starts to be interesting because you remember we have here the IXP00. I think it's like the same directory name. Yeah, IXP00. What is the connection here? Okay, step one for okay, this over okay, server save one, delete the registry value. So try to understand. Run once. Okay, this is why it got to run once. Okay, search and delete this folder. So okay, then gets and deletes the files. Wow. Okay. If I want to understand, like maybe the developer of this malware took some code from other malware, whatever, I go to integer analyze. So let me just real quick log in and then I'll get back to you. Okay, so we are back here. Uploaded the file, the first stage, Ardamax X, and see what do we have here. So it has some genes with some kind of installer, 75, 79 genes, extract, whatever it is. Okay, get current directory, set current directory, get this free space, moldy, get information. So it goes and do function analysis. So if we search about what is extract, so regarding there is a legitimate process which is responsible for extracting compressed Windows cab. So all of this is based on an extract program, which is basically part of Windows. Yes, Windows System 32. So if I go to the virtual machine, we'll learn a lot about Windows. Say Windows System 32, extract. Okay, extract. This is the first time I see it. Yeah, you can be 30 years in this field, not 30 years, something like 10 or 11 years, but you can be 30 years in this field, and again and again and again, you will always learn something new. Okay, so legitimate stuff abused for malicious purposes. Yeah. Okay, so this is what it is. So this is why it has. So all of the dropping mechanism is based on the cab files inside the resource section, and the extract exe is used to extract the files. And yeah, so basically this is what it is. Let's see what can we also, okay, if we go to one exe, we see so this it's actually a great tool because it shows us that Ardamax took a lot of genes from the Hawkeye malware, which is another keylogger. Yeah. Okay. Yeah. So they have a connection. So it's like I always say, malware analysis is not only for blue teamers. It's a lot more for red teamers, because we are, as red teamers, want to simulate or emulate a specific APT group or specific tests or use cases. And as you can see, most of the threat actors will go and deploy some sophisticated or some simple malware inside your organization. It will not be always like somebody goes into your organization or your network and implement Cobalt Strike or Metasploit or whatever. Most of the time today it's Cobalt Strike, as the people in this field knows. And yeah, so as you can see, and as I always say, APT groups or adversaries, attackers in general, learn from each other, learn techniques, learn from each other's code. So I can, as a red teamer, take malware, reverse engineer it, understand its mechanisms, and re-implement it as my own tool or my own malware. Of course, for if I'll do it for white hat or good purposes, everything legit. Yeah, so basically we learned a lot about it. And if we continue researching our sample, so we can now go and let's do save as the database itself. Want to save it on the desktop if we will need use it again. So let's go with first stage, can close it, pack database. It will pack the database, all its files. So for now we can go and continue analyzing the second stage, which is one exe, and understand its capabilities. So we already saw, we suspended the process that it initiates a connection to some HTTP server. Okay, so let's start from beginning. So let's first of all understand what type of file it is. So let's go use PEBear for this purpose. So go to, so of course it's an executable, 32-bit from what I see here. Yeah, 30-bit. And let's see what kind of section it has. So it has resource text section, very minimized sections. Maybe it's packed or whatever. Yeah, I think it's packed because you can see also the import table is kind of small. So let's use die or detect it easy to detect if there are any known or unknown packers. Okay, so nothing. So maybe, okay, so let's put in P Studio also to get more indications, because why not? And also let's use CFF. So it's .NET assembly actually. It's not C++. Yeah, we saw a lot of .NET string stuff in the first stage and other indications that we search in Google. So this is okay. So this is the internal name, fully exe, fully. It's like something Italian. I don't know. copyright, something, whatever. Okay, so basically it's a .NET assembly, which means we can load it in the NSPI and not in IDA. Okay, so IDA is for C++ compiled binaries, and the NSPI is for .NET compiled binaries. So we see that it uses some Commodore certificates, I think, as to log into your Gmail account. Maybe it will log into to the attacker's Gmail account, which is used like a C2 or as an exfiltration receiver, whatever. See a huge. Okay, so we have password, registry, so a lot of indications here. This name was detected before. This name also was detected before. If we go to our store, we'll see that it has MZIL, Microsoft IL, like the IL assembly. So MZIL is another indicator that is actually a .NET binary. What else we can learn about this? Let's see. Maybe some interesting strings. Okay, we see some selects here, and always as I see selects is like, okay, it goes for cookies. No, not the ones in the cookie jar, but the ones in your browser. Okay, so let's validate it. If we go here to whatever it is, C memory, execute, release, Visual Studio goes to Visual. So takes username, password, stuff from your Chrome or other browsers, and yeah, so it's a potential info stealer, as we already saw. Keylogger. So it's more than a keylogger. Don't just like it's not like just logging your keystrokes. It does a lot more than that. Okay, so we call it Ardamax Keylogger, but yeah, as you see, it does a lot more. So let's try to see what else. Let's see if we can do by blacklist and resource. Go to resource. Use some anti-write virtual memory. We see here the use of set Windows hookx, which is actual MITRE technique. Attack MITRE is a great framework for mapping and understanding attackers' techniques, tools, and procedures. Okay, so this is the meaning of TTP: tools, techniques, and tactics, techniques, and procedures. Okay, and of course, Attack MITRE also shows you a lot about attackers and their tools and stuff like this. So set Windows hookx, as we already saw in my first video, and like in a very old variant of Ardamax, is used for hooking or keylogging. Okay, so it's interesting. It also goes for enumerating processes. Okay, so it has a lot of interesting capabilities. I don't see that it's actually packed. If it were packed, maybe it was like I will not see the actual strings here. And this is the way of .NET binaries, the way they work. Like you maybe see less stuff in the imports and more stuff as a strings, but again, it can be very complicated, and maybe I'm not explaining the stuff here precisely. Okay, but for me, it's enough to see. You go see email address, pop account, see a lot of weird and problematic stuff. Okay, so we can go and take this binary and put it in the NSPI. Okay, so loaded this sample into the NSPI in my host, actually, because I didn't have the NSPI in my virtual machine. Forgot about it. Okay, so go here. Let's see if we have Let's see what kind of resources we have here. Something with C memory execute. Stuff with memory always fascinates me. Stuff with process injection, stuff like this. Mail PV, get mail. Okay, so I think it also has some interesting resources maybe that we can use, analyze. So maybe if we go to resource hacker, okay, we have some stuff. So basically icon, don't really interesting. Okay, so if we go to version, so here's the manifest, also not something interesting. It is executed as an invoker or as the user context. If it's a regular user, it will run with the permissions of this regular user. If it's an administrator, it will run as the administrator user context. What else? Web browser pass view. So maybe it will actually pop up, please log in with your Gmail account or whatever. Okay, so if we go to my application main, okay, create some form. So it actually, I think it actually tries to literally not only like log your strokes and initiate a connection to some C2 web server and enumerate cookies and stuff like this from your computer. It actually tries to do a phishing attack also. Maybe we can continue executing the malware we have in the virtual machine and see how it behave. So create process we have here, creates a whatever process. So okay, if we go here back, okay, so create some process. Maybe it will create the process of install exe, which is the, I think, the third stage. Anti-unmap view of section can be used for unmap or hallow content from DLL. So do DLL import and call this. So the anti-unmap view of section is from the anti-DLL library. So I think it's actually obfuscated in some way. Tries to take 2 arguments. Get rid context, create process. Yeah, it's all literally obfuscated. So string, build string builder. I think it's actually the obfuscation function. This is what I think. Maybe I'm wrong. Okay, so then it takes all this information, creates a process, reads the process memory, hallows, allocates, and write process. Okay, so we found basically a process injection code or mechanism inside this sample in this second stage. So basically it will go and create some kind of process if we let it continue and execute, and we'll inject hallow and then inject the process content, and then we'll do resume thread. So this is the P injection using process hallowing technique. So run PE. Okay, so this is the name of the method or the class, whatever. Yeah. So yeah, all of this is part of this interesting. Okay, so this is the injection. See here, goes for clipboard. So again, if I go to folder here, clipboard, change clipboard chain, Maybe it tries to take stuff from our clipboard. Set clipboard viewer. If we go and search whatever information we have on this function, so as a special window to the chain clipboard viewers, see new viewer, whatever. So if we go and put the magic word malware, let's see what else of new. Ah, here you go, Hawkeye variant. There you go. Yeah, so Ardamax basically, and again hexacorn. These guys everywhere. Great job, man. So yeah, so it's like Ardamax took from Hawkeye or whatever, did some mishmash here. Threw us to check the clipboard content has changed. Okay, so get clipboard, get set clipboard viewer. Wow, interesting stuff. We have a blog Fortinet here. Do some. Okay, Excel, PowerPoint. So actually, I think again it's like a theory with a lot of evidence, but whatever. I think Ardamax like saw this Hawkeye code and decided, okay, why not? Let's learn from it. And it's like, okay, and so Hawkeye is also .NET executable, as we saw. Ultra pros VBCX. So this is the pros that we see. So wow. So I called my videos Ardamax, and it's actually a Hawkeye. Maybe I need to go and rename my videos. It's, but okay. So Hawkeye says a keyboard logger with set Windows OKX, and again, it's very similar to how Ardamax operates. So I will not change the name of my videos, I think, but it's kind of interesting to see it. We have here everything about this Mambo Jumbo keylogger. As you saw, it goes for Chrome, Yandex, and those browsers. And we saw all those select commands executed, SQLite based queries like SQL and stuff like this. And it goes and login URL, browser name, user and password, and okay. So all this collected information collects the client's login, username, password, but also profile information. So this is the actual keylogger, which will be which is like this is the actual injected or created and injected process, which will do all of this stuff to detect reverse SMTP, and all of this will be exfiltrated using SMTP. I think it's like Ardamax learned from Hawkeye and Hawkeye learned from Ardamax. Maybe they're the same group or some kind of mishmash. I don't know, whatever. Yeah. So eventually it will do all of this stuff. So I think I can actually stop, because I think we got the general idea. You know what? Let's just go here, resume. Okay, we see here so let's resume this body, this mishmash thing. I'll call it mishmash from this day, and it supposedly need to create this vbc.exe process. Let's acknowledge. I don't know. It tries to check. Maybe it will success. Maybe not. Maybe it will check whether the C2 server is alive. If so, it will create. If not, so no. We can check this logic. But again, this video is I think it's already 50 minutes, so let's try to wait maybe. Okay, so I don't really see something is happening here with one exit. So basically I will leave it for you, something that I will try to like make you maybe get this answer why it actually do not create this VBC exit process and inject in content. Maybe it will do maybe an hour or 2 hours or whatever. Try to check maybe which kind of test it does. Maybe try to go to the code, to the literally to the dnspire or .NET code, and try to understand why it actually happening. Okay. So basically, it was very fun for me to do this those 3 videos of Ardamax. I have a lot of community requests on doing other stuff like analyzing and researching about how tools are working, offensive tools, like more malware, ransomware stuff. So I'll do and try my best to do videos weekly or every 2 weeks. And yeah, that's it. So if you like this video, please subscribe, do like, the bell button, all this algorithm stuff, which I don't really understand how they work. And basically, thank you very much watching this video, and see you in the next one. Take care.